welcome. This is Math 111. And this is section 2.8, as you can see. All right, so first thing we're going to talk about linear models. Obviously, a linear model is a linear function who has the form y equals mx plus b. Remember, f of x is just a fancy way of saying y. And m and b are constants. A linear model is basically when you look at a bunch of data that looks like it forms a straight line, and then you kind of fit a line of best fit, a line that gets closest to most of the points. Then we have two specific models that we're going to talk about. One is direct variation, and that is just a fancy way of saying a line that goes through the origin. Right? A line that goes through the origin, so it just has a slope. So instead of being y equals mx plus b, it's just going to be y equals mx. Usually, instead of writing m, they use the variable k as its kind of its variation constant, but that's just a fancy way of saying slope. So if it varies directly, it is simply a straight line that goes to the origin. If you hear something says varies directly or varies proportionally, it just means it goes through the origin and has a slope. Now this one, inverse variation, is what happens if you have some constant and you're dividing by x, and that's not even linear. That looks something like this, right? So it's kind of like misleading. They kind of act like these are two of the same thing, but they're totally not. This is completely different. This means that when you multiply x times y, you get some common constant k. So, and then if you were to solve for y, you'd get k over x. So this is a very misleading name. When they say inverse variation, you want it to think that it has something to do with direct variation, but it truly doesn't. It really, one is a line and the other one is a completely different shape. I suppose you can argue that since y equals kx here, if we were to solve for k, then this would be y divided by x equals k. And over here we have x times y equals k. So they're making this note like this is multiplication and this is division, and those are two inverses of each other. But when it comes to graphs, they're completely different shapes. So just something to keep in mind.
Those are hyperbolas,
All right.
Those are
1 over x's?
The x, y times
Yes.
k is a hyperbola, right?
Yes. It's a degenerative hyperbola. So in general, a hyperbola would look like this or this, like that, and that's not what we have there. So that it's degenerative. It's not exactly the same as a hyperbola. So let's go ahead and take a look at some examples from our text. Okay, let's take a look at a couple of example problems. Depreciation, this is question number 1 from the homework. Depreciation is the decrease or loss in value of an item due to age, wear, and market conditions. We usually consider depreciation on expensive items like cars. Businesses use depreciation as a loss when calculating their income and taxes. One company buys a new bulldozer for $108,000. So company A gets a bulldozer for $108,000. The company depreciates that bulldozer linearly over its life of 23 years. So it depreciates over 23 years. It's salvaged at the value of 23 years. At 23 years, it's valued at $13,700. Express the value V for bulldozer as a function of how many years old it is. Make sure to use function notation. So if I wanted to do this, I would say V of t. This is going to be something, a function value of time is equal to m times time plus some b. Now, when it is 0 years old, it's worth $108,000. We know that, right? So we know that $108,000 is a point in this graph. We also know that 13,700 is a point in this graph. And so we want to see what this slope looks like over time. So if I find the slope, I would take this minus this over 0 minus 23, which using my calculator, I would find be 24,300 divided by negative 23, which would be negative 4,100. It's essentially saying that this is reducing in value every $4,100 every year. So V of t is equal to negative $4,100 times t, the number of years old it is, plus 108,000. And that would be my equation for this. And I would write the whole thing, V of t, just like that in the MyOpenMath as my answer, using t as my variable. Okay. And it says, what's the value of t in 4 years? So I would just take that times 4, negative 4,000 times 4, plus 108,000. And my value of my bulldozer in 4 years would be 91,600. Let's skip down a couple and take a look at question number 9. Question number 9 says, suppose y is directly proportional to x. Directly proportional means that this is going to be in some form y equals kx. Right? If the constant is, find the constant of proportionality, find k, if y is 21 and x is 5. So k is just going to be 21 over 5, which goes in 4 1/5, so 4.2. All right. Using k, write the equation. So I would write y equals 4.2x. Using k from above, find the y when x is 13. So 4.2 times 13 is 54.6. Okay. So again, I would just say y equals 42 times 13, 54.6. Let's take another look at a story problem, like number 19. The force F in pounds needed on a wrench handle to loosen a certain bolt varies inversely. That means y equals k over x with the length of inches of the handle. All right. So the force equals some k over the length of the handle. If a force of 35 pounds is needed and the handle is 5 inches long, a force of 35 pounds is needed when the handle is 5 inches long. if a person needs 25 pounds of force to loosen the bolt, estimate the length of the wrench handle. All right. So they gave us this so we could figure out what K was. And then we're going to plug in K and go from there. So K is equal to 35 times 5, which is 175. So we have Y equals, and again, I used force here. I could have used force or length underneath. It doesn't make a difference in these. 175 over my length. We want to solve for my length now if my force is 25. So how long does this have to be, this handle have to be? So if I go 25 times L equals 175, multiplying both sides by my length, dividing both sides by 25, and I need a 7-inch wrench. Okay? So I will let you guys spend some time working on this assignment, and if you have any questions, just let me know.